Uranus' hidden heat, new discoveries challenge old theories. Hold on to your hats, Uranus, that quirky ice giant in our solar system, might not be as chilly as we've all been led to believe for years. New research is shaking things up by revealing that this tilted planet is actually radiating about 15% more energy than it absorbs from the Sun. If that doesn't pique your curiosity, just wait until we dive into the surprising twists that challenge everything we thought we knew about planetary heat. Uranus has always been the odd one out in our solar neighborhood. Picture this: it spins on its side, so one pole basks in sunlight for a full 42 years during its version of summer, while the other endures a long, dark winter. And to add to the strangeness, it rotates in the opposite direction compared to most planets, with only Venus sharing that backward spin. This unusual setup has fascinated scientists, but it also made early observations tricky. Back in 1986, NASA's Voyager 2 spacecraft zipped by Uranus and collected data that painted it as unusually cold inside. This finding threw a wrench into basic theories about how planets form and change over time. For decades, experts assumed Uranus lacked any significant internal heat, which was puzzling because the other gas giants don't behave that way. But here's where it gets controversial: relying on just one flyby measurement might have skewed our understanding, and now, fresh analysis is calling that into question. Dr. Amy Simon, a planetary scientist at NASA's Goddard Space Flight Center, puts it this way: after Voyager, the consensus was that Uranus had no internal warmth, but that never sat right with many in the field, especially when you look at planets like Jupiter, Saturn, and Neptune. Those giants pump out more heat than they get from the Sun, a remnant of the intense energy from their formation 4.5 billion years ago. In contrast, Uranus seemed to be in perfect balance, absorbing and emitting equal amounts, which suggested it might be older or had lost its heat due to some catastrophic event, like a massive collision that could have even caused its sideways tilt. And this is the part most people miss: those hypotheses didn't hold up under closer scrutiny. Some scientists wondered if Uranus was just ancient and had cooled down, while others pointed to that potential giant impact as the heat zapper. But none of these ideas fully explained the data, leaving a big question mark hanging over Uranus's thermal mystery. To crack this cold case, a team led by Professor Patrick Irwin from the University of Oxford dove back into decades of observations. They used sophisticated computer models that incorporated everything from hazy atmospheres to seasonal cloud patterns, drawing on data from telescopes like NASA's Hubble and the Infrared Telescope facility. The goal was to nail down Uranus's energy budget. Think of it as the planet's personal accounting sheet, where you track incoming solar energy against what's reflected back as light and what's released as heat. By accounting for how much sunlight bounces off at different angles, they discovered that Uranus is actually more reflective than previously estimated. That means less energy is absorbed, and when you crunch the numbers, it turns out the planet is generating about 15% more heat than it receives, aligning with findings from a separate study. This revelation puts Uranus in a new light. It's not as heat efficient as we thought, though it's still nowhere near as toasty as Neptune, which blasts out more than double the energy it gets. So, what does this mean for our understanding of planetary evolution? Well, that remnant heat could be a clue to Uranus's history, perhaps tied to its formation or those wild axial tilts. But don't get too comfortable with this picture yet, because interpretations can vary widely. Now, here's a controversial twist to consider: if Uranus does have internal heat, does that debunk the idea of a massive collision stripping it away, or could there be other factors at play that we're overlooking? Some might argue that this heat is negligible and doesn't change the big picture, while others see it as a game-changer for how we model planet formation. What do you think? Could this lead to a rethink of solar system dynamics, or is it just a minor adjustment? Share your thoughts in the comments. I'd love to hear if you agree or have a different take on this icy enigma. Uranus, the surprising heat of the ice giant. Scientists have made a fascinating discovery: Uranus is surprisingly warm, generating more internal heat than it receives from the Sun. This revelation challenges the long-standing observations made by NASA's Voyager 2 probe nearly 40 years ago, which suggested that the distant gas giant was not particularly warm. Led by Xinyu Yang from the University of Houston, a team of researchers analyzed decades of data from various spacecraft and computer simulations. Their findings indicate that Uranus emits approximately 12.5% more internal heat than the solar energy it absorbs. While this is significant, it still pales in comparison to other outer solar system giants like Jupiter, Saturn, and Neptune, which release about 100% more heat than they receive from sunlight. The implications of this internal heat are profound. The researchers believe that understanding Uranus' heat could shed light on the planet's unusual tilt and its origins. This suggests that Uranus is still gradually losing residual heat from its formative years, which is crucial for piecing together its history and evolution, Wang stated in a recent announcement. In 1986, the Voyager 2 probe made a historic flyby of Uranus, providing much of the current knowledge about this enigmatic planet. At that time, it appeared that Uranus did not exhibit significant internal heat. However, it seems that Voyager 2 may have observed Uranus during an atypical period, as some of its data could have been affected by a spike in solar activity during the flyby. By revisiting a wealth of archival data and integrating it with advanced computer models, scientists now propose that the internal heat of Uranus could suggest a vastly different internal structure or evolutionary path than previously thought. It is believed that Uranus formed around 4.5 billion years ago, alongside the rest of the solar system, and NASA posits that it originated closer to the Sun before migrating to its current position in the outer solar system about 500 million years later. These new findings, however, cast doubt on this established narrative. Wang emphasized the importance of this research, stating, "From a scientific standpoint, this study enhances our understanding of Uranus and other giant planets." The insights gained from Uranus' internal processes could also assist NASA and other space agencies in planning future missions to this distant world. In 2022, the National Academy of Sciences identified a mission concept known as the Uranus Orbiter and Probe, UOP, as a top priority for planetary science in the coming decade. However, even before the significant budget uncertainties that arose following President Donald Trump's budget cuts, scientists recognized the challenges of launching such an ambitious and costly mission. Lee Fletcher, a planetary scientist at the University of Leicester who contributed to the Decadal Survey, remarked, "We face numerous obstacles, political, financial, and technical, so we are under no illusions. We have about 10 years to transition from a conceptual mission to actual hardware ready for launch. Time is of the essence." Regardless of whether this new research bolsters support for the Uranus mission, scientists are already celebrating these findings as groundbreaking. Liming Lee, a co-author of the study, noted that understanding Uranus' internal heat not only enhances our knowledge of this distant icy planet but may also provide insights into similar processes occurring on Earth, including our changing climate. By exploring how Uranus retains and dissipates heat, we gain crucial insights into the fundamental mechanisms that govern planetary atmospheres, weather patterns, and climate systems, Lee explained. These discoveries broaden our understanding of Earth's atmospheric dynamics and the pressing challenges posed by climate change. The study detailing Uranus' internal heat has been published in the journal Geophysical Research Letters. Join our space forums to continue the conversation about the latest missions, night sky events, and more. If you have any news tips, corrections, or comments, feel free to reach out at community@space.com. Brett, a writer with a keen interest in emerging aerospace technologies, alternative launch concepts, military space developments, and uncrewed aircraft systems, has contributed to various publications including Scientific American and Popular Science. He holds degrees in English from Clemson University and the University of North Carolina at Charlotte. In his leisure time, Brett enjoys stargazing in the serene Appalachian Mountains. Confirmed, Uranus is hotter than it should be. What's going on inside the ice giant? **** confirmed, Uranus is surprisingly hotter than expected. ***. Uranus, the seventh planet from the Sun, is known for its unique characteristics, but one of its most intriguing features is its ability to emit internal heat. Despite this, the exact composition of its interior remains a mystery. Recent research, drawing from decades of observations, has confirmed that Uranus emits more heat than it absorbs from solar radiation. This significant finding, reached by two independent research teams, finally addresses a long-standing enigma that began when Voyager 2 flew by this peculiar planet in 1986. At that time, data suggested that Uranus was not releasing any excess heat, which contradicted the behavior of other giant planets in our solar system. A study led by planetary scientist Xinyu Wang, who previously worked at the University of Houston and is now at the University of Michigan, has determined that Uranus emits approximately 12.5% more heat than it receives from the Sun. This conclusion aligns with earlier findings from a team led by planetary physicist Patrick Irwin at the University of Oxford, which were published earlier this year. Wang explains, this indicates that Uranus is still gradually losing residual heat from its formative years, which is crucial for understanding its origins and the changes it has undergone over time. He adds that this research enhances our comprehension of Uranus and other giant planets, reinforcing the argument for future exploratory missions to Uranus. Interestingly, previous studies have indicated that the Voyager 2 flyby occurred during a period of heightened solar activity, which may have caused Uranus to exhibit unusual behavior. Therefore, it is not surprising that some of the data collected by the probe may not accurately reflect the planet's typical state. However, the results from Wang's team suggest that there are still peculiarities associated with Uranus. For comparison, Jupiter emits 113% more heat, Saturn 139%, and Neptune 162% more than they receive from the Sun. Given that Neptune is located further from the Sun than Uranus, the distance cannot account for Uranus's comparatively lower internal temperature. This raises questions about the internal structure of Uranus or aspects of its evolutionary history that remain unexplained. The researchers emphasize the importance of investigating the often overlooked outer planets of our solar system. In their paper, they advocate for a future flagship mission to Uranus, which would yield vital observations to tackle the many unresolved questions surrounding this enigmatic ice giant. The findings have been published in the journal Geophysical Research Letters.